My name is Abhijith. I'm an engineer here at Hedvig. So I'll be giving you a demo of the entire system. I'll try to cover almost all the topics that Bharat spoke about. So this is what a web UI of Hedvig looks like. So this is a cluster that spans across 4 different DCs. SNC1 refers to one DC, SNC2 is the other DC, SNC3 and SNC4. And these are the storage nodes within the DC. And what you see here, the number 8, the number 1, those are nothing but the storage proxies, or you can call them the controller VMs. Now, as Bharat spoke about, each storage node runs 2 processes. This is the one that's on the left is the pages process, which keeps track of the metadata, and the one on the right is the HBlock process. So let me just go into one of the HBlock processes. So what you see here, these are the storage pools, right? So each storage pool, as Bharat mentioned, is made out of a set of disks. Now, since you guys are also introduced to the concept of containers, if I click on a storage pool, you'll see that containers are assigned to storage pools. Now, I can hover over these containers. For example, this is one of the vDisks that is running a VD bench test. So the name of the vDisk is, this is the name of the vDisk, and towards the end you see a dollar, that whatever comes after the dollar is the container ID. So 29th container for this particular vDisk is assigned to this storage pool, which is storage pool 4 on this particular node, which is hedvig1.snc1. So this is how easy it is to actually visualize the data in the system. So now for the purposes of the demo, so this is a cluster that we use in-house, which mimics one of the customer deployments that we have out there, and we use this for our nightly runs. So as you can see, this shows the amount of data that's actually present on each one of the nodes, right? For the purposes of the demo, since we'll be doing data center outage and things like that, I'll switch to another cluster that we have set up, which is again which spans across 3 different data centers, and it has 3 nodes per data center. So let me move on to the virtual disk management page. So this lists all the virtual disks that you have actually provisioned in the system so far. Let me quickly go to the add disk page. So these are all the attributes that you can configure at the time of creation of a virtual disk. So you have to give a name for the virtual disk. Let me call it demo block. A size for the virtual disk, so let's say I create a 40 gig disk. Disk type can be of it can be either block or NFS. The disk type will automatically be set to object if you are actually creating the virtual disk either using OpenStack Swift or S3 APIs. Now a few other options. RDM is for raw device mapping. You can enable deduplication, you can enable compression, you can also enable client-side caching. This enables the block cache, which is there. If block cache, if you have an SSD at the storage proxy, this will enable data to be cached for this particular virtual disk at the storage proxy. Then there's one more option called cluster file system. So for example, if you provision a block device and you want to put something like a VMFS file system on top of it, you check this option and we'll know that it's a clustered file system. Then replication policy. So as Bharat spoke about, you have 3 different replication policies: agnostic, data center aware, and rack aware. Let me choose data center aware. So when you choose data center aware, you'll see that we'll populate this with a list of all the data centers that are available, and you can choose which data centers you want this particular vDisk to be replicated on. So I'm just going to choose all of them for the purposes of the demo, right? And if your replication policy is data center aware, you'll see that replication factor is actually determined by number of data centers you choose. If you choose 2 data centers, replication factor automatically becomes 2. Block size is 4K by default, and disk residence can be hard disk or flash. Now what this means is that you can also have storage pools which are made out of flash in the storage service. So if you choose the disk residence as flash, we'll ensure that all the replicas for this particular virtual disk reside on flash storage pools across the storage nodes.
Will it now itself be smart enough to say, okay, data center 1 and 2 are near to each other, but 3 is far away, or do you set that somewhere else?
You will have to set that based on your knowledge of your data, your environment, when you choose which data center you want to replicate it into. You see what I mean? Like, let's say on the previous cluster that he showed you, you had 4 DCs, right? No one better has a better knowledge of the network topology and the latency between data centers than the customer, right? I'm not going to claim that I do know it, right? Can I learn it over time? I could, but I still can't recommend where you or a customer would want to place their data. They should have that flexibility.
Okay, but you said you write 2 before you acknowledge.
Yes.
So the third will be the...
We want the customer to be aware of the fact that at least 2 out of these 3 are close to each other. So you choose accordingly.
And then Hedvig will be...
Yes.
Okay.
So the latter part is taken care of by us. We'll write to the 2 closest replicas, and the third one gets written in an async manner. So I just created a virtual disk with the properties that I just said. Let me just open it to... So as you can see, this shows a snapshot of all the properties. Now, since you have not written to this particular disk yet, this does not have any containers assigned to it yet, right? So the next step in the workflow is you have to do, since this is a block disk, the terminology that we use is synonymous with that. So now this list will be populated with all the storage proxy that you have available. So you have to select one of the storage proxies. Now when you select one of the storage proxies, what happens is this particular virtual disk gets added as a LUN onto that particular storage proxy, and the storage proxy now masquerades as an iSCSI target, right? So this particular VDisk has been added as a LUN onto this storage proxy. Now let's say you want to write to this particular block device that you just created using one of your clients. So to do that, what you need to do is you need to give access to one of the clients. So we have, I have one client in our lab, and I'm going to just give access to that, for example. So I've given access to this particular client to write to this VDisk. So now let me switch to the client that I just gave access to. So this is the client, Wood CLNT2. Let me show you the list of disks that it can see so far. So as you can see, these are the only disks available. So all that you need to do right now is, this acts as an iSCSI initiator. You just have to log into the iSCSI target, and you'll see the disk that we just provisioned appear here automatically. So let me do that.
So while he's doing that, I think this gentleman, Enrico, is that your name?
Yeah.
No, sorry. All these things that he's doing through the UI, they are actual APIs that are exposed via REST. So anyone can script against it and build their own orchestration into the system.
If you do that, do you also, while he's doing this in the UI, will that also be translated to a script that I can use directly for the next time I'm going to do the same thing?
You can do the whole thing using a script, or even the provisioning.
Yeah, but you did a couple of steps now.
Yes.
Is that also being translated into an API-driven script that I can use next
So you
time
can copy and use
copy?
someplace else. She's on fire.
We can do that, but I don't think we do it today. But he's going to show you the whole orchestration mechanism in the next step, which will perhaps answer the question that you had initially posed.
So if you look at this, I ran this command. So this is nothing but internally running a iSCSI ADM command to log into the iSCSI target, and once I did that, you'll see that it got this disk. Now this shows that it's coming out of wood cvm1.snc1.hedviging.com, which is the storage proxy that I just used, and the LUN number associated for this particular virtual disk was LUN number 3, right? And you can do nf disk -l. So you'll see that the size is what I created. So now I can switch back to the UI, and let me just quickly resize the disk before I actually write into it. So I'm going to resize the disk, change it to, let's say, 50 gigs, run. So once your disk is resized, all that I need to do here is just do a rescan, and you'll see that I just have to rescan for this disk on the CVM, and if you'll see that the size has been reflected. So now let me quickly put a file system on top of this and show you guys that how the containers are assigned for this particular virtual disk.
So the motivation for showing this is that it's a modern system, but it blends itself into the existing workflow, right?
So, but it uses the IP address of the proxy to log into the iSCSI target.
IP address or host name? I gave the host name here.
So, if that proxy is down for some reason, is it failing over, or another node is taking over the name or the IP address?
So the way it works is we have a floating IP and a floating host name, which is assigned to whatever is the active proxy which is running at the moment. So if one guy goes down, since it is HA, the floating IP and host name move over to the active guy. So this won't be affected.
Okay.
And
is there like a timeout period or something? Is it happening immediately?
Yes, it happens immediately.
Okay.
Right, so as you can see, I've just put a file system on top of this log device. Let me switch back over to this disk and show you the containers. So as you can see, some containers have been assigned, and if you guys remember, I chose a data center aware replication policy for this. So the system should ensure that any container that has been allocated so far should always span across data centers. So if you can see, demo block 1 is in SNC 132. This property holds good for every container. The second container is in SNC 132. Right? This is how we ensure that anytime we allocate a container, it satisfies the replication policy that you have chosen for the vDisk.
And all this state is actually kept in the metadata process that he was talking about in Pages.
I mean, I would say most customers are not necessarily concerned about, which containers and where they're located. They're concerned about overall capacity and things of that nature. Yeah.
Yes. I mean, this is just for kind of expounding on the idea that he presented. This visually, you can look at everything that is happening in the system, and they are all exposed via APIs that you could script against or program against for any kind of information that you might need.
Okay, so the next thing that I'm going to show you is snapshots and clones. So let me just go ahead and take a snapshot of this particular virtual disk. Now, snapshot is a metadata only operation in the system, so I can just take as many snapshots as I want. So this is actually creating snapshots with just a click of a button, since it's a metadata only operation. So once you have created these snapshots, as it was previously mentioned, you can create clone out of it. Now, when you create a clone out of a snapshot, you have the flexibility to change the policies, and this is what we spoke about earlier. So let's call this clone, say demo block, and since I chose data center aware policy for the base disk, I can go ahead and change the application policy completely, just make it agnostic, and can just create the disk. Right now, if you look at this, the replication policy is agnostic, and it also shows you what is the base disk that this clone was created from, and what is the base snapshot used to create the clone. And the clone is of type shallow, so which is why it doesn't take any time for you to create a clone out of a vDisk. Is this clear? All right. So for the next part of the demo, I have written a script to just showcase the API-driven functionality. So what this script is going to do, the demo.py is the script. So what this script is going to do is, it is going to talk to the cluster entirely using REST APIs. And for example, let's say you have a VMware environment, and you would have your own automation scripts to, let's say, provision VMs and do things like that. So I've written a small VMware automation script as well. So what this is going to do is, it is going to provision storage at the Hedvig side. It is going to mount the particular virtual disk as an NFS data store onto one of the ESX hosts that we have, and it's going to provision VMs on top of the NFS data store. And as and when your data store runs out of space, it's going to resize the vdisk and put more VMs on it, right? So let me just go ahead and run the script.
So you present the ESX as NFS then?
Yes.
That would be our recommendation, yes.
So the vdisk created, this is the name, NFS Demo vdisk. Let me quickly switch to the, so this is the disk, NFS VM, sorry, not this one, Hedvig NFS Demo is the disk, and as you can see that the VMs are being provisioned, right? And if you see, the size of the data store is currently 50 gigs, and the VM is of size 40 gigs. So when it goes to the next VM, it's going to resize the disk first, the data store first, and then it continues to put, there you go, it changes to 100 gigs, and it's going to put more VMs on it. So this is going to continue for, let's say, I think 5 VMs or something. So this is how easy it is to actually use our system completely using the API interface that we expose and integrate it with any existing automation that you have, for example, for VMware or any other ecosystems. You can do the same thing with OpenStack as well, if you have an OpenStack deployment.
Do you have like a NFS 5 VAI plugin?
Yes, we have a plugin as well. So the plugin, the things that you can do with the plugin is you can provision whatever storage that you provision on the Hedvig UI. The same options will be available through the plugin. You can create a virtual disk, assign policies, do everything. And once that is done, you can also select a DRS cluster or a single ESX host to actually create a data store on. And for any VMs that you create on the Hedvig data store, we allow you the option to create a Hedvig snapshot of that particular VM and clone out of it.
Yeah, okay, but I was talking about the VAI plugin.
VAI plugin for block.
Yeah, not for NFS.
We support for
Not the entire gamut.
Yes,
we support a small subset. There's still certain things that we are working on.
The snapshot and clone operations for NFS is provided through the plugin that we have for VMs.
How about vVolt support?
Not
It's
yet.
coming in the road. It's in the roadmap. It's not there
You
yet.
are on VMware's HCL though for NFS?
No. So as you can see, it has completed the creation of 6 VMs, and it has appropriately resized the data store whenever it wanted to. This is what I wanted to show you about the API-driven integration.
What's the warning on that virtual disk status?
This is the ESX.
No,
They're on the data
there's a
store.
warning designation on that status for.
I think it's getting full or something like that, I guess, because you've put 6.
100 gig with 60 gig free?
Yeah.
It may have stayed from before.
All right, so that's what I had to show you guys about how easy it is to provision things in the system, and also how easy it is to actually look at what data is persisted on what nodes and how the containers are assigned, and also how we can easily integrate with any existing ecosystems out there. Any other questions? All right.
You had this on a version 5.5 environment. 6.0 is supported as well?
Yes.
It is.
Can I see how much space is in use now through this interface for this particular volume? Is it like thin or?
It's thinly provisioned.
It is thin.
It is thin.
Yeah.
So you can also browse, for example, let me just show you a few things. This is, not this one. Yeah, this is the disk that I just created. Oh, where is the disk?
But you can see it on a container.
The containers would have not been assigned to any of so for example, each VM here has its own VMDK associated with it, and since I've not installed any operating system on it yet, so nothing has been written to it yet, right? So anything that gets assigned only at the time of the first write. So we treat each virtual machine's disk, the VMDK itself, as its own virtual disk. We internally treat it as its own virtual disk, and containers get assigned to a VMDK.
But you created like 6 VMs?
Yes.
Which have 240 gigs in use now on this NFS data store. Can I see somewhere in the storage interface or on container level or vdisk level how much space is in use, or it's just curious?
NFS Demo vdisk. So this is the disk that we just created. Now these are all the VMs that we just created. Now this itself gets treated as a virtual disk. Now let me go log into one of the CLIs. So to answer your question, we don't keep track of that particular information, where we try to see how much space is allocated for a particular data store, because it's entirely dependent on how many containers are actually assigned so far, right? So to answer your question in a different way, so let me log into one of the nodes.
There is some level of detail that we didn't get into as far as how VMDKs are presented via.
Yeah, okay.
There's some amount of detail that we didn't get into in terms of how, when we use NFS, in order to retain that single writer status, so that you don't have to be grabbing distributed logs, how we kind of circumvent that. I think we'll need to show you some of that in order to completely grok where the utilization is coming from.
Yeah, okay, but I was more curious if it's like visible how full the containers are, or
it is in a roundabout way, not through the VM.
Yeah, okay.
We can show you offline how that.
So one thing that I would like to show you is this. If you look at the UI, I've picked one of the VMs, which is demo 1, and this is the disk associated with that VM, the flat.vmdk. And since I said that we internally treat it as its own virtual disk, which gets containers assigned, and the name of that virtual disk is 1428. Now, if I switch back to the CLI, just to show you the CLI as well, right? There's a command called describe vdisk. I run it on 1428. It shows the properties of that particular virtual disk. Now, this is associated with Hedvig Demo 1, right? And if I query for containers, you will see that there are no containers assigned for this yet, because you have not written to it yet.
So if I just create an NFS volume for a VMware cluster, and I've provisioned a bunch of vdisk to all my VMs that are out there, there's no way for me to see how much data I've actually used of that volume?
You will be able to see looking at the container usage. How many containers?
No. Yes. Right. Well, yeah. Even like just in the UI of this interface, is there any way that I can actually see that? So like if I want to just like create a big 4 terabyte volume and just throw all my VMs in there, can I see how much of that data has actually been used, so I know how many more VMs I can actually provision?
Not through the UI today, but we can get that information if needed.
Okay.
There's a lot of little things about the UI that we can be more do a better job of, but it's not there today.
So, how would you provision out a new proxy?
So we provide you with an, if you're running it as a VM, we'll provide you with an image ISO. You can just install it on a virtual machine, and there's a config file which is inside the proxy, and you have to point it to your cluster, one of the cluster nodes, and it'll automatically start talking to the cluster.
And does it use some sort of tokens or keys to authenticate itself?
No.
So if I come in and I'm a nasty person who decides to be somebody who's spoofed your API and looked at the data and done a bit of sniffing around, I could pretend to be a proxy?
Today we don't have any access control at a proxy level. If you choose to do so, yes.
Ooh, okay. That's the sort of thing I like to try and do, because that can be dangerous.
But if you want to make sense of the data, good luck, because it's so distributed and it's all kind of stored in our own binary format.
Not saying it would be easy. I'm not saying, but that's the sort of thing where I think you'd want to make sure that somebody couldn't come in and pretend to spoof being a proxy.
Agreed. I think some of our customers are hence asking us to see if we can provide encryption, and we are conflicted between whether we want to have them run SEDs or provide encryption ourselves. Right? Providing encryption at our end should be relatively straightforward. Forget the key management stuff. It will just be a policy that you can turn on or off again. Right? So it's easy to kind of build on top of the same building blocks.
So are you planning to do a kind of lightweight virtual appliance to run your proxy?
So why?
It is available as an OVA that people will just import.
Okay.
Yes.
I don't know if I missed it, but is there a way to see like total cluster data usage?
Yes.
Yes.
Okay.
So let me switch to the other cluster, and here is the total use space. This is across all the nodes. So it has a total capacity of 171 terabytes, and that's what it's totally is used. And we also show it at a per, this is again just an aggregation of the data that we show at a per DC level. You'll see that this data center is 45% full, that is 40%, this is 15, and that's 17.
So when you do like a virtual disk, is it automatically thinned, or can I also do thick provision
No,
disks?
it's always thin.
It's always
Always thin? Is there any way to see provision size versus use size?
like I said, we can calculate that. And now that I'm not completely lying, because we do show you all this information. You'll have to know how to navigate through this to actually get it. There are certain aspects of the UI that we continue to work on in order to show that, per vdisk, used and unused. But we can get that information if you want to.
Going back to Chris's question about the deployment of the proxy.
Yes.
You said it was an ISO. Is it a virtual appliance that actually you deploy and actually fill out information and it's deployed that way on top of, or is it a Linux environment that you have to configure?
No, the proxy is an OVA that you can just import.
It is an OVA?
Yes, it is.
Okay, I was just...
No, I think he was referring to as to how, when he says ISO, I think he's referring to what goes on the storage nodes. We can give you an ISO that comes pre-bundled with our software, everything.
Okay. Right.